In this lesson, we're going to be looking at what are called piecewise functions. And piecewise functions are basically when you put two or more equations together, and you're going to use different domains to split up your graph. So that's the big topic for today. We're going to do a few things with it. We're going to evaluate, graph, write our piecewise functions, and look at a specific one called a step function. Okay, so if you look at this concept right here, you'll see, for example, this is an example of a piecewise function because it has two equations, and you'll see there are what are called constraints, which basically tell you the domain of each piece of the function. And then it together creates one larger picture, which is called the piecewise function. So you look at the top one, f of x is x minus 2, only when x is 0 or negative numbers, right? And then f of x will be 2x plus 1 if x is a positive number. And you can see there are these two distinct pieces, right, of the graph. We have the x minus 2, which is this one down here. And then we've got our 2x plus 1, which is this piece up here. And then it combines to make one picture. So when we evaluate, like in example A, we want to look very carefully at the constraints. So again, the constraints are what x can be. So we want to know what we're plugging into when we evaluate. So for example, if x equals -1, which one of these does that match up with? Well, -1 is less than or equal to 0, so I want to use f of x equals x minus 2, because I want to make sure I match the constraint. Okay? So then I'm just going to go ahead and plug in -1 for x, and then f of -1 will equal -3. Make sure you're using your function notation here. Okay? So same deal for the second one. When x is 1, I want to think, what does that match up with? Well, when I plug it in, right, 1 is less than or equal to 0. That's not true. But 1 is greater than 0. So that means I want to use f of x equals 2x plus 1 based on what's up here. So then if I'm going to go ahead and plug in my 1 for x, then f of 1 is going to equal 3. Right? So again, just check those constraints. When I look at 0, I can say when I plug in 0 for x, is that 0 less than or equal to 0? Yes, it is. So I'm going to make sure I use the top line, f of x equals x minus 2. Plugging in 0, f of 0 equals -2. So what you really want to watch out for, again, is make sure you pick the correct function from the piecewise function, right? Correct equation. Okay, go ahead and try the U-try problem, and let's come back and check. Make sure, again, you look carefully. There's 3 different pieces now. So when you're checking those constraints, see which one makes a true statement, and then plug it into the correct function. All right, go ahead and check. A couple things I want to point out. Number 1, notice how there's no x here when f of x equals 3. Well, that means you can't plug anything into it. So no matter what you plug in for x, you will always be 3. So this is an example of a flat line. So just remembering that, right? A horizontal line. Okay? Then hopefully the others are pretty straightforward. You're just seeing which ones fit into which constraint, making sure you see the less than or equal. So the 5 fit in the middle, right? Whereas the 10 goes to the last one with 4x. All right, if you have questions about how I get these numbers, please come to class with those. And let's look at one more piece. Let's look at graphing our piecewise functions, and then we'll do the rest in class. So if I want to graph the piecewise function, I want to look at the 2 different pieces, and then I want to put it onto my grid, and then I'm going to ask you to describe domain and range. So the first thing I want to do is figure out what each of these graphs look like. So if I look at this -x plus 2, I know my y-intercept here is 2, and my slope is -1. So again, my slope here is -1 over 1, and my y-intercept is going to be 0, 2 for just this top equation. So if I wanted to graph it, I can start at, labeling my line first, or my number lines. So I'm going to start at 0, 2, and then go down 1, over 1, right down 1, over 1, or up 1, right 1, and this is that first line, right? The second line, y equals 2x. Well, I know that the slope is 2, or 2 over 1, and there's no plus b, so that means the y-intercept must be 0, 0. So what I can do then is go ahead and graph that. So I can start at 0, and I'm going to go up 2 over 1, right, up 2 over 1, or I can go down 2 over 1. And then I have these two separate lines, right? But what I want to do is I want to make sure I'm erasing and cutting it off where the constraints are. So the blue line should be where x is 0 or below 0. So that means I actually don't want all of this in blue, right? So I want to erase everything here that is positive, and then I want to take a look at the sign, and this means I want a closed circle. So I'm going to go ahead and make sure that's a closed circle at 0, 2, and this should be the piece of just that blue top line on my piecewise function. Okay? Then I want to double check my red line. Oh, and I just erased all my numbers. Let me put these back in. Okay, perfect. So the red line is where everything is greater than 0. So what I want to do is, first off, let's erase all the negative parts. And then the question is, should 0 be open or closed? Well, the sign clearly says it's not equal to 0, so this should be an open circle. So I'm going to go ahead and replace that with an open circle, and then this is my completed piecewise function. Now, obviously, if you don't need to draw and erase, you can feel free to just draw it in just like this, right? But if you feel like better to draw the line first and then go back and erase what you need to, you're welcome to do that as well, like I just showed you. Okay? Now let's go back and look at domain and range. So remember, domain is which one? Well, it's the x, right? And range would be the y. So if I look at the domain, I want to think, going to the left, does it ever end? And you look at the arrow, no, it doesn't. Going to the right, does it ever end? You look at the arrow and you're going to tell me no. Then the last thing I want to think about is, what about this open circle? Does that create a gap or one point where x can never hit? And the answer there is no, because even though there's an open circle here, we have a closed circle. So at 0, y is 2, so we do have a value. So we're going to say all real numbers for domain. Okay? Now the range, we want to look top down or bottom up, right? And you want to think, does it ever end going down? Well, yes, I do see something ending right here and that number is 0, and there's nothing below 0. So y's got to be greater than 0. Does it end anywhere going up? Well, the answer there is no, right? The arrows are going up forever, so we know we don't have a maximum. And then the last thing I want to do is look at the circle, and it's an open circle, so that means y can never be 0. So y is greater than 0 is my range. Okay. Now I know sometimes domain and range can be difficult, so please come back to class with questions, especially if you didn't understand why it's all real numbers and not everything but 0, okay? But try out 7 and 8 on the U-try. So we're going to come back and do 9 in class, right? And we'll talk about writing the piecewise function in class. But try out 7 and 8 for me, and let's see what we get. Don't forget to talk about domain and range. All right, so go ahead and check your graphs first, making sure you've got your two pieces. And if it helps to do what I'm doing, you can always color code, right? So I did the top in blue, the bottom in red, and I'm double checking my domains or my constraints, right? So I'm stopping the blue at 2 with the closed circle, starting the red one at 2 on the x with an open circle, right? For 8, starting or stopping the blue at -1 with an open circle, because looking at those constraints. And then for the red, starting at the -1 with the closed circle, because it's greater than or equal to, and going forward. Then check your domain and range, and let's come back to class with questions. Thanks for listening.